Welcome to Maritime Pakistan, your gateway to the fascinating world of oceans and the opportunities they present to every one of us. Our goal is to explore the shared heritage of the seas and oceans to achieve global prosperity. Today's discussion explores the book, The Sea and History, the Ancient World. Our discussion will focus on the 16th chapter, Mediterranean Ship Technology in Antiquity.
Okay, so let's dive right into this explainer. I want you to close your eyes for just a second and try to picture the ancient Mediterranean. We're talking about a totally bustling, incredibly high-stakes environment. You've got hundreds of oared warships clashing to decide the literal fate of empires, right alongside these giant, heavy merchant vessels that basically served as the ultimate superhighway of the ancient world. But when we really stop and look at this, a massive question comes up. How on earth did ancient empires build vessels capable of dominating the seas without any modern blueprints? Well, to answer that, here is our roadmap for today. First, we'll look at the ancient maritime world. Second, shell versus frame construction. Third, mortise, tenon, and sewn hulls. Fourth, warships and ship design. And finally, number 5, the economics of innovation.
Let's kick things off with Section 1, the ancient maritime world.
Take a look at this incredible marble relief excavated from Carthage. It dates all the way back to around AD 200. Notice that large, multi-masted merchant vessel carved right into the stone? Ships exactly like this one were the absolute lifeblood of the era. They were out there moving vital resources, commodities, and thousands of those heavy transport amphorae across massive empires. It's really an iconic representation of the vessels that completely defined the era.
Moving right along to Section 2, shell versus frame construction.
So, it turns out there is a fundamental difference in ancient shipbuilding philosophies. It's like two totally different ways of solving the same puzzle. On one side, we have shell-based construction. This means the builders actually started by edge-joining the outer planks together first to form a watertight shell. Think of it like building an eggshell before dropping in passive frames later just for some reinforcement. Now, on the other side is frame-based construction. This is where builders create an internal skeleton of frames first, and only then do they attach the outer planking to that skeleton.
To truly grasp this frame-based method, we really need to understand the concept of active frames. These are the internal framing timbers that are erected initially in a frame-based building system. The absolutely crucial point here is that these specific frames play a vital role in dictating and defining the exact shape of the vessel's hull planking. They are the actual skeleton deciding the boat's shape, which is a complete 180 from the shell-first approach we just talked about.
All right, Section 3, mortise, tenon, and sewn hulls.
If you're building an eggshell first, how do you hold it all together? It all comes down to a highly resilient locking process, a remarkably simple but incredibly effective 3-step method. Step 1, the shipwrights would cut cavities, known as mortises, directly into the thick edges of the softwood planks. Step 2, they'd insert hardwood tenons, usually made of tough oak or olive wood, right into those cavities to join the adjoining planks together. And finally, Step 3, they lock the entire joint securely by driving wooden pegs straight through both the plank and the tenon.
You can see it perfectly in this diagram. Just look at that precise 3-step sequence and notice how snugly the hardwood tenons fit into the mortises before being securely pegged into place. This exact, meticulous joinery is exactly what allowed ancient shipwrights to build those massive self-supporting wooden shells. I mean, these things were strong enough to carry incredibly heavy cargoes across the rough, open ocean, all without an active skeletal frame holding it up.
But get this, mortise and tenon wasn't the only way they did it. There was actually a completely fascinating alternative known as the sewn hull tradition. This started with the Greeks in the mid-1st millennium BC, and it actually survived all the way into the Roman era in the northern Adriatic. And yes, builders literally stitched their ships together. They aligned the planks with small dowels and then physically drew the edges together using tough cordage passed through holes. After that, they'd slap some waterproof wadding over the seams to keep the water out. It's a completely different yet incredibly successful regional take on the shell-first method.
Which brings us to Section 4, Warships and Ship Design.
Now consider this breakthrough insight from the text. Shell-based shipbuilders relied upon methods of design that were based upon simple geometric rules of thumb conceived on a transverse rather than longitudinal basis. For a really long time, historians basically assumed these shell builders just eyeballed the whole shape lengthwise as they built. But recent research shows something amazing. They actually used highly sophisticated, repeatable geometric rules of thumb based on a transverse or cross-sectional design concept.
Looking at these cross-sectional diagrams of varying ancient hull forms, we can clearly see how these geometric design rules allowed builders to adapt the shape of the hull perfectly to whatever its specific job was. You can see the whole spectrum here, from flat-bottomed coastal traders that were designed to navigate shallow waters up at the top, all the way down to deep, open-water keels that were built specifically for stability on the high seas.
And when it came to ancient warship engineering, that consistent design was absolutely paramount. I mean, Hellenistic warships required standard, repeatable forms for fleet consistency so that every single ship handled the exact same way in the heat of battle. They primarily utilized that super strong mortise-and-tenon shell construction we covered earlier. But perhaps the wildest part is that their heavy bronze naval rams, like the famous Athlet ram, were not just bolted on at the very end as an afterthought. No, they were integrated directly into the structural wooden shell of the hull itself. That requires some truly incredible pre-construction design.
And now for our final piece of the puzzle, Section 5, the economics of innovation.
If we chart hull construction and sailing rig technology out on a timeline, a really dramatic transition becomes super clear right around the mid-first millennium AD. The thousands of years old shell-first method slowly begins to phase out. It's replaced first by mixed construction and eventually by fully frame-first skeleton construction. And right alongside this massive shift in the hull, we see the rise of the fore and aft lateen rig replacing the traditional square sail.
And we have the concrete archaeological proof to back this up. The early 6th century AD, Dor 2001/1 shipwreck, which was excavated right off the Israeli coast, is the absolute earliest fully frame-based vessel excavated so far. No mortise-and-tenon shell building here at all, just a pure skeletal frame-first construction.
So the crucial question we have to ask ourselves at this point is, why? Why did a shipbuilding tradition that dominated so incredibly successfully for literally thousands of years suddenly just change? What on earth drove this massive technological revolution? And you know, the mystery only deepens when we realize that, structurally speaking, these new frame-first ships weren't actually any faster, nor were they better performing in the water than the old shell-first ships.
Well, the answer, and really the narrative climax of our whole explainer today, lies in the economic drivers of change. Frame-first builds required significantly shorter construction times. They also allowed for the use of a smaller and perhaps less highly specialized workforce. All of this resulted in drastically reduced maintenance costs over the entire lifetime of the ship. Plus, it perfectly aligned with a strategic shift towards smaller, more numerous vessels in late antiquity, which was mostly due to fragmented economies and capital shortages. So the best innovation, as it turns out, is often simply just the most economical one. And this brilliant economic theory connects directly to the ship's rigging, too. The transition to the lateen sail offered absolutely no improvement in speed whatsoever. But what it did do was significantly economize the creation and the maintenance of the rigging. So even the most iconic sails of the era completely changed strictly to save money and labor, rather than to actually boost sailing performance.
Which leaves us with a pretty provocative thought to ponder. In an age of rapid, non-stop innovation like our own, how often is our modern technology driven primarily by budget and efficiency rather than pure performance? It's kind of fascinating to realize that the exact same constraints driving ancient Mediterranean shipwrights all those centuries ago might be the exact same forces driving our own tech industry today.
We hope that you liked today's video. Please share your comments and subscribe to explore other similar opportunities. Post your questions in the comments section for future videos.